Hello and welcome to this repair tutorial, and today we're going to look at a Pioneer, and this is the A10. In terms of general specifications, power output RMS is 30 watts per channel into 8 ohms, but this will increase to 50 watts if you have 4 ohm speakers connected. From the front fascia you can have 2 sets of speakers connected, so speaker set A and speaker set B, or if you want private listening via the headphones jack socket, you can just switch those off. Frequency response is 20 Hz to 20 kHz. Total harmonic distortion is 0.01%. And then for your inputs, the amplifier supports a moving magnet type input. So if you have a record player, you can connect directly with no requirement for any form of equalizer or preamplifier. Tuner input, CD, aux, and then network recorder. And you also have a recorder output on the rear. And you can select the loudness mode. And if you wish to bypass the tone control circuits, you can do that with the direct mode. In terms of dimensions, width 435, depth 360, height 128 millimeters, with a weight of 6.7 kilograms. What's important to note with this amplifier is that it doesn't support any form of remote control, so everything is manual from the front. If you wish to have a remote control feature, then you need to go to the A20 or the A30 amplifier. Now, when we look from the top here, with the cover removed, you can see the main amplifier board. It's quite busy. There's a lot sort of going on there. And with this particular amplifier, and this also goes with the A20 and the A30, there are really two very common issues. And the issues that you see are related to voltage regulators and also to the power transformer. And one of those issues was the reason why this amplifier came into the workshop. Here what you can see is an extract from the service manual. And what we're showing you here is the microcontroller. With the microcontroller, it is located on the front control board, and then during manufacture what they do is they just flash the firmware directly into the microcontroller. The microcontroller is really doing a lot of different functions, and you can see here if you zoom in that you have both inputs and outputs. The bit that I'm interested in as an engineer is that this amplifier, when you powered it up, the power LED should normally be blue, and what I saw was that it's flashing red. So that tells me that this amplifier is in protection mode. And that protection mode is all done by the microcontroller. So what you have is multiple inputs for different types of fault detection. So it could be over temperature, it could be a voltage issue. And once that is detected, the amplifier will then latch the protection mode. And the only way in which you can clear it is with the amplifier powered on and the LED flashing on the front. You need to press the direct button and speaker B push button together for a period of 5 seconds or longer. What you'll then hear is that the startup relay at the back will energize, and then, all being good, the amplifier should clear the protection mode. Now that's if it's what we term as a soft failure. It detected something, but it wasn't, for example, a hardware issue. You need to do that if you're going to be doing any form of testing when it's in a fault condition, i.e. pressing those 2 buttons. Because that will enable you to do is to make a number of measurements. So let's get into that first of all. What I'm showing you here is one area which is a very common issue, and this is the failure of the plus and minus series regulators. And they are manufactured by KRC, which is Korean Radio Corporation, and they are a very well known and established brands. And you don't just find that brand of regulator just in the Pioneer series. You may find them, for example, in other amplifiers like Marantz. And what happens is that internally they go short circuit. And then if you try to measure the output voltage, and here you have the 7915, which is the negative voltage regulator, and the 7815, either of those will fail. Now, if the amplifier is in protection mode, you've got to come back to what I said earlier. So you've got to press the direct button on the speaker B, and then connect your multimeter probe on the first voltage regulator, and just check what that output will be. And then on the second one, you'll probably find that it's starting to collapse or it's not there, but the other voltage regulator appears to be working correctly. And then here I'm just giving you the example where I've got the multimeter lead connected to one of the regulators, and if you look in the distant background you can see the multimeter and it's reading 0 millivolts. Now what you have to do is really remove the back cover, and then you've got to remove multiple screws, including the screws underneath which connect through to the heatsink. And then once you unplug all of the different multi-pin cables, you can remove the circuit board, and you'll see that later in this repair tutorial. what I do here is I'll replace both of those regulators. Even if only one of them is faulty, I'll take the opportunity to replace both, because I know from experience, and I've repaired many of these amplifiers, that that is going to be an issue either right now, as in a fault, or it will manifest itself at some point in time, and that's going to be, an issue for the owner of the amplifier. Now, the other most common issue, and that was the fault with this amplifier, is the failure of the power transformer. So here, what we're showing you is an extract from the service manual, and then what you can see then is the EI transformer on the right hand side. And what happens is that there is an internal thermal fuse, and this thermal fuse goes open circuit, resulting in no voltage from the secondaries, and there are multiple secondaries on this transformer. And then you can also see that I'm highlighting a small power relay, and what happens here is that the microcontroller, when you first power up the amplifier, provided it's not in protection mode, then it will then send the command to the power relay, and it will then energize and then provide the mains voltage via the switching contacts to the primary of the transformer. As soon as it goes into the fault condition, then you'll need to do this resetting of the amplifier just to verify to see if you actually have any voltage on the secondary of the transformer. Now, you don't have to put it into your multimeter into AC measurement mode to do that. What you can do is you can just go back to the plus and minus 15 volt regulators and just check the voltage to the inputs of those regulators. They should of course be higher than 15 volts DC. But remember, you have to press the two buttons, which is the direct button and the speaker B. You'll hear the startup relay energize after about 5 or 6 seconds. You can quickly make a measurement and then verify if you have voltage or not. Now, what is really odd is that if you try and obtain any spare parts for any integrated amplifiers that Pioneer manufacture, you appear not to be able to source any of these components. But if it was a car audio requirement for those types of amplifiers, or maybe for DJ mixers, etc., plenty of support. So here what I'm showing you is the EI transformer, and what I've done is I've removed the connection directly from the startup board, and then I've got my multimeter connected, and this is in resistance mode, and you can see that it's reading overload at the rear. So that tells me that the primary of that transformer is open circuit, and really there's nothing we can do. As I said, you can't obtain a replacement transformer. So rather than leave the customer with the situation where they have to buy a brand new amplifier, what I've done is I've had made, and I have these in stock, a toroidal equivalent, and that's what you can see here. So what I've got is like a nylon 7 mounting plate, and then I'll mount the toroidal transformer with its rubber anti-slip mat underneath, and then it just bolts through into the existing holes where the EI transformer went in. Now, when you actually take the amplifier apart, and then I'm coming back to this point where I remove the plus and minus 15 volt regulators, what I have to do also is just to verify that there's no dry solder joints. This board is manufactured with lead-free solder, so it's a little bit more difficult to determine, because sometimes you have to look very clearly, because with lead-free solder it's always sort of dull grey anyway. But what I do find is from time to time on these circuit boards you just see some cracking around some of the component pins, so it's just a case of just reflowing them. And then once that is done, remember, because we have replaced the transformer, what we need to do now is we need to reset the bias or the idle current for the left and the right channels. So on this extract from the service manual here, you can see that we are showing the left channel. And what we're looking to do is to measure across the test points, and there's two, one for the left, one for the right, and you are looking to read directly 8 millivolts. Now there is some tolerance as you see here, so this is plus or minus 2 millivolts. And then you'll also see onto the circuit board with reference to the respective channel, there is a small preset variable resistor, and this is what you will adjust until you are reading the correct reading on your multimeter. What's a little bit strange in the service manual is they sort of just say, well, just warm the amplifier up for about 3 minutes, which seems a very, very short space of time for stabilization. For myself, I normally leave the amplifiers for about 10 or 15 minutes and then make the adjustment, but that's what's written in the service manual. But in terms of inputs, again, what the service manual is saying is you select the CD/SCA mode, and then you're going to set your tone control, so bass, treble, and balance controls to midpoint, and then your volume to minimum with no speakers connected and no input, and then you would then make the adjustment. So here on this photograph, what we are showing you is the initial measurement. And if you're sort of eagle-eyed, you can see that there is a connector which is plugged directly into the multimeter and then just goes into one of those test points. I've just made the plug up, so I'm not sort of balancing multimeter leads. And you can see that it's reading 6.92 millivolts. You can also see as well the toroidal transformer. And then to the right hand side where you see the power coming in, that is your startup board where that relay is located, and then that small EI transformer is the startup transformer, which after rectification, smoothing and then voltage regulation provides the required voltage to the microcontroller, which is a surface mount device. You can sort of just make it out on the left hand side nearest towards you on the main board mounted vertically. And then here what I'm doing is I'm just adjusting it, so it's about 9.98 millivolts. So that's the initial adjustment, and I sort of brought it down to about 8.2 millivolts, which was within the required range. This being for the left channel, and then of course you would then repeat that exercise then for the right. So once that was done, you have to carry out a full functional check, and as expected, the fault here was that the transformer was open circuit on the primary. So once it had been replaced, no sort of issue. And then here when we kind of look from the top, you can see the amplifier in its entirety in terms of the different circuits. If you look on the right hand side, you can see that there is a multi-pin Toshiba device. This is the input IC, so there's no mechanical switching as such, and there are no input selection relays. You also have, again on the right hand side towards the rear, that is your moving magnet phono stage. And then here what I'm showing you are the removed fail components, so EI transformer, and then these are the two voltage regulators, the KRC 7815 and 7915. And then finally we put the amplifier on test. So here I didn't need to sort of run it for 4 or 5 hours because it wasn't that type of fault in terms of nature. It was the transformer, as we said. So I just do a full operational check. I also just clean the user controls as well and the headphone socket. But the good news here is at least this amplifier then can deliver, a number of years of good, reliable operation, and there is no need to replace it or to throw it away. I'm not sure really if that was sort of like a design issue with these EI transformers, but you'll find the same issue with the A20 and the A30. So it's a little bit disappointing because any sort of investment in any integrated amplifier by a customer or by an owner often is not insignificant. And if you have these types of, say, regular type failures, then it's really down more so to a design or to a manufacturing issue rather than anything to do with the environment or the way in which the customer is using the amplifier. So that sort of brings us to the end of this repair tutorial. So I appreciate you stopping by. And as always, if you need any help, guidance or support, by all means email audioamplifierservicing@aol.com and I'll be more than happy to come back to you and provide any support. So until the next time, I wish you all the very best. Cheers and bye-bye.